All right, so we're talking about representations for text. Um, in the notes in the calendar, I think I called it document clustering or document classification. And that's true. That's what you want to use it for. But then as I was looking at it again last night, just loading up the slides, and actually what we're doing is only focused here on how to represent text data. All the algorithms we talked about so far, and that we will talk about, decision trees and k-nearest neighbors, and we'll talk about SVM and neural networks. You can use classifiers as long as you have some features that describe the data well. You can build a classifier or a regression system or clustering to basically do different things with the data, right? And that's what we're learning as we talk about those algorithms. But as we talked about in the previous week of lectures that were all the online ones with feature extraction, right? You did PCA and LDA and all those things. Hopefully I know people have looked at a bunch of these early videos. Hopefully you've looked at all of them at this point. Those are really important methods for extracting useful features from data that might not have been present in the data in the first place, right? Because as you're finding with your COVID data, it's an interesting data set, but those numbers may not always be the most useful thing. They're useful for certain stuff, like if we use the latitude and longitude and age, those are probably useful, but the other ones, are they all useful? Sometimes you'll have a data set where some of the features just seem really weird, but a combination of multiple features might give you something useful, right? So PCA, and LDA and those methods you looked at, they find numerical correlations and patterns amongst a bunch of features, and then give you a new feature that merges them all together, right? And says that, here's, 5 principal components that represent your 100-dimensional data set, and these 5 principal components are basically new rotated dimensions in your data set, so that each of them has very high variance, right? So the data is spread along that dimension to a large degree. And so they're very distinctive and they describe major patterns in the data, right? So that was useful for numerical data that you can talk about it having, the values full ratio numerical data, right? That spatial, you could plot it spatially and it means something. PCA and all those methods help you do that. But what if your data is text, right? We've talked about numerical data. We will talk more about images. We've talked about them, I guess, a little bit. We talked about categorical data and labels. But what if your data is text? Human speech, words. It could be English, but it could be any language. So you have words, letters usually, but at least some kind of symbols representing meaning, and those symbols put in order to express ideas. Right? That's what language is. The problem is there's a lot of it. I guess these are larger tasks for what you might want to do with text data. But, all right, I had a reference thing for myself. Right? So the idea is, how do we deal with words in a way that is useful, right? So that's a tricky problem because words aren't just numbers. There's no ordering of them. You can't say this word's more important or higher than another. It just seems like it'd be very hard, right? If you try to think of it as a computer, what do you do with text, right? Because letters aren't meaningful on their own, you'd assume. And in some languages like Chinese, there's no letters. Each character is quite meaningful, but the relationship between a number of characters is not in any way linear or simple, right? Like in English, the way letters relate to each other side by side isn't related to meaning. The words relation between them is related to meaning. In Chinese, each character's relation to each other has like a little bit of meaning, but every 4 or 5 characters could be a phrase and an idiom that means a particular thing, and now the relationship of those together is meaningful, right? So, and other languages are more alphabetic, so they're more like English in that way, that, the things that your data points are, the smallest level, basically are almost meaningless, or at least have very little levels of it, and there's this larger grouping that have meaning, but even then it's not linear, right? So how do we do this? So basically there's a couple different ways of doing it, and people have converged. This field is changing a lot, so I'm giving you my basically current understanding of it, but it is literally having a revolution right now in this field. So the things I'm talking about today and probably tomorrow are really kind of the foundational things. And people have moved on from some of these, but they still use these concepts underneath. But now they build more complex models on top. So let's go through the idea. So things you want to do with text. I mean, all of search engines, the fact that you're reading news stories and everything, documents have been grouped and ordered and sorted. Humans don't do that manually, right? I remember in the internet at the beginning, they did, like Yahoo search. What was it? It was even another one before. Yeah, it was Yahoo. Search engines before Google had people manually organizing documents and saying, okay, these are useful groupings. Here are documents on medicine. Here are documents on sports. We'll group them together. We'll do a little bit of automation. And it was, you'd search, but it'd be like, how often do your search words match categories that people came up with, right? And so they try to automate these things. You can imagine how good that was and why when Google happened, it's like, oh, this is so amazing because they were fully automated. And it actually isn't related to the stuff we're talking about today. So they used this stuff, but then they did something else clever, which we should talk about it later. But documents, like web pages are documents, sports articles, news articles, books, movies are documents. How do you combine them together? So there's lots of useful things you'd want to do. Sentiment analysis is a popular thing to, at least a few years ago, to apply to like surprisingly impressive. What's the mood? What's the tone of an article? Is it happy or sad? Are these people, what kind of emotion are they having? You can kind of group together documents if you have enough data and try to infer that. But in order to do that, you have to turn this text data into something numerical with features that we can understand. And so that's what we're talking about. So this preprocessing we've talked about before. For normal data, for numerical data, in text there's additional preprocessing specific to language. And so every language would be different. This is the example of how to do it for English. I guess two main ones that they talk about, we stop word removal. So like if you're writing something in English, you use the word the and to a lot, right? And those words don't necessarily add any meaning to telling you what the sentence is about. They're very important grammatically, but they're not even that important grammatically, right? In some languages, you don't have the in the same way we do in English. You just drop it, right? And it's not really critical, right? English is weird. So you could just drop the most of the time and people could still read the sentence. And you might not want to drop it, but you could probably get through it, right? There's many words like this, you could realize that, oh, maybe they're not necessary to the meaning of the sentence, right? If you could understand it by dropping the word, it's probably just a stop word that could be removed. So the standard set of stop words that you kind of prune out and just basically delete them. Stemming is another thing, right? So if you've got an article that says computer and then somewhere else says computing and then says computer science department and computation, they're all talking about computation and computing, right? So in a sense, if you're just looking for the high level topic about what the article is about and whether, this web page is about the same thing as this other web page, you could just replace all of these words with comput, and you'd be good, right? Because in English, comput probably means you're saying something about computing or computers in some way. And so in terms of general topic of the document, this word would be sufficient. So you do things like that. So that's called stemming. You basically knock off, treat it like a branch, you stem, you prune off some of the letters on the end of every word that are just grammatical. So you can do this with basically all the words. And based on every language, you might have different things you remove that way. But English is standard settings. I'd assume this is harder to do in Chinese. Because I always mention Chinese because it's such a different language written-wise, because there's no tense and there's no thing like that. There's little words that may not be important, like, counting words and good and stuff, but it's probably more complex because each word is kind of inherent on its own. So punctuations, so Jason's asking about, do we remove punctuation as well? So that's a good thing to think about. Should you remove punctuation? Think about it. Depends. Right? Might be really important, right? So, periods are really useful, right? Maybe commas. You could remove commas. Depends how much grammatical testing you're doing. So, like I said, I'm just doing a high-level thing. If you're going into NLP or using that, there are vast sets of policies and knowledge on this. You can do a grammatical analysis of sentences and figure out how words relate to each other. And in those cases, commas might be really useful because they'll tell you, sub-clauses in the sentence. But if it's just at a high level trying to figure out topics, I think commas are often ignored. I think periods are not, though, because that tells you which sentence, where they begin and end, right? And so it could be useful if you do sentence level learning. You could basically train your model on sentences one at a time from the document. Then it could be very useful. But it depends. And some of the models we built will basically ignore punctuation because you're just talking about counts of words. But yeah, if you're doing any kind of analysis of sentiment, as Sophia is saying, yeah, if you're talking about the mood of a sentence or a text, question marks and exclamation points would be even more important, right? So it depends what you're doing, right? But it's not as obvious that you just remove it, right, as these things. Some of the things we talked about already, like mutual information, we can use these as ways to score and decide if we're keeping certain features. But we also want to define some based on documents and their own internal structures. So this document frequency statistic is something new that we have to define. So there's a bunch of different approaches, and I was trying to update this on the weekend, but it's like I said, it's changing constantly. So I think some of this is a little out of date, the vector space stuff. But there's this basically increasing complexity of approaches of how to represent documents. What we're trying to do, though, is to find some way to turn these words and their spatial relationship into something that we can analyze numerically, and it's not going to be just noise, but we want to get at meaning, hopefully, and you'll see we'll get to that. That hopefully there does seem to be some kind of meaning represented in there. So in terms of this classic way of doing it with the vector space models, you have a couple choices, right? You could take pair patterns, right? So you could find pairs of words. I don't see anyone using this anymore. That's why I'm forgetting how it works. It's old. It's 2010. It's so old. Usually I wouldn't say that, but in text, that feels old. So they'd find correlations between particular words from the data and try to see if they show up often near each other, right? And so they could learn that, carpenter and wood are related, and you try to build features that way. A much more common way that we'll talk about is this term, document, and word context approach, where basically these are getting more general as we go. So when we say context, we're talking about the context of words in a sentence. So you have a bunch of words and you want to say, are they related to each other? Are they important for this document? This slide should probably come later because I haven't defined it yet. So here's a picture. Let's be a little more concrete. So we're gonna have, so here's your document. So every document, well, these are the documents. For every document, we're gonna say it has a bunch of words, right? So a single document has a bunch of terms, right? We just say every word that's separated by spaces or punctuation is a term, and we'll call that a term here. So you've got n words or terms in each document, and you've got a bunch of documents of this structure, right? And so now, these are all the words, basically, like these are the vocabulary. So I can't write on this slide today. You have a vocabulary of all possible words that show up in your documents. Let's say you've got a website, right? All the articles on the Toronto Star website. You have news articles, it's a newspaper. You get all those articles and you distribute them out, right? So all the words that show up in any document are your terms or your vocabulary. And then you could describe a document if we want to turn it into numbers, right? We're trying to find a way to turn a document of text into numbers. One way to do it is to say, for all of these words, so every possible word that ever shows up in the Toronto Star, you could just take the Oxford Dictionary or something and say, here's all the possible words. They all have a number, right? Every word has a number from 1 to n, and we use that number as an index. And then for every one of those words, we're going to say, well, how often did that word show up in the document? We're just going to count it, right? So TF is term frequency. So how many times does this term, so the word, I'm not going to say the word the, so the word computer, right? How many times does the word compute show up in this document? And you'd have a number, and then how many times does the word football show up, and the word orange juice. You'd have a count for each of those, right? And so that's a way to turn each of these documents into a vector of numbers. So let's go back to this definition a bit. So our idea is, in this vector space model, is that you want to come up with a way to turn a document of text into a vector of numbers, and then we treat that vector as a space that we're going to do pattern recognition and machine learning and optimization in, right? So once you've got a representation of a bunch of numbers for your document, you can use any of the other methods we've talked about. There's some tricks that are specific because we know that they're words, that they're more useful in a certain way. But this is the main idea, that we find some way to turn that document into numbers, and that vector of numbers is that. So it's a very large vector, right? There's all the vocabulary of possible words, and most of them are going to be zero, right? Because most words don't show up in any particular document. The ones that aren't zero will be some number that tells you how often that word showed up. So it's a weird data set, but technically is a vector-based data set there. How much time? Okay, I got 5 minutes. So once we've got some way of turning that into a vector, and we'll talk about different methods you can do. Term frequency is just the simplest. Right, well, this is also called a bag of words, because essentially we're saying there are a set of words in existence, essentially the dictionary, all possible words, and every document is essentially a bag of some of those words and how often they showed up. So we throw all the words into a bag and we count them. So bag of words is the way people talk about it. You can just see BOW in like documents about in NLP descriptions. So for every document you have, you've now got these term features, and then you could put a count, right? And obviously you could normalize them because you know what's the maximum number of words in the document. And so you can say, well, 10% of the document is this word and 30% is this word. Or the frequency could be normalized based on all words. But if you go by that particular document, you've got something that tells you what proportion of the document is that particular word. And you'd hope that documents that are about the same topic would have a similar pattern, right, of words. So this is kind of an assumption that we can make. Where is my slide on that? Oh, I skipped it. There we go. That's why I should change the order of these. The assumption, which is called the distributional hypothesis, is that words that have a similar context have a similar meaning. So in terms of the entire documents, we're talking about articles on Toronto Star, and then we count them, just count how many words show up, and then you use those vectors now as a distance score, and you could do classification on that, or just basically compute all the documents that are kind of close to each other based on those vectors. There'd be a whole bunch of documents about ice and hockey pucks and sticks and nets, right? So it'd be all the articles about hockey on the Toronto Star, which would be quite a lot of articles. And there'd be less articles about soccer and some articles about, you know, finance and banking. But each of those types of documents, those clusters of documents, would probably have pretty similar word vectors, right? So ice and puck would only show up in hockey documents and very rarely show up in banking documents. And so you could use those number vectors as similarity score between documents, which could help you say that they're kind of more similar or near each other, right? So the context in this bag of words approach is the whole document. So the meaning of the words in that document is that this article is about hockey. And so the context is the whole document. Now we can also say that the word context could just be the neighborhood around a word. So you take a word and you say, okay, take a window of like 5 words or 10 words around that individual word, before it and after it, and that's the context. And so then you compute your scores for every word based on something relevant to its neighbors. And so these more powerful methods like word2vec and glove, which we'll talk about tomorrow, use that, and it's quite popular. At the beginning, people often just used document level statistics, if you just want to say, are these documents similar or not? So I'll stop there just as the introduction, because that's our hour and a half. So any questions just for clarifying? And then we'll continue from here tomorrow. Okay, so we have a question about magnitude and direction, because we're getting a vector, we're treating it as a vector, and that's a good question, right? What would the direction of this vector mean? And it's not clear it should mean anything. It's just like a vector in a high dimensional space. But one of the powerful things of some of these methods, where am I? Especially Word2Vec kind of showed this first, but now a lot of them do this, is that you come up with an encoding. So these term document counts are at the beginning, right? So we use those as a way to count something. We also didn't do some things about, the neighborhood of a particular word. And then we're going to do some actual machine learning and come up with a new encoding and do some feature extraction. So kind of similar things that you talked about with PCA, but actually using, for Word2Vec, they just use logistic regression, and they fit a model and come up with a new encoding. And that vector then is what gets used for every word. And in that space, directions do have meaning. And so it could be gender, it could be temperature, it could be sport versus banking. So one of the goals of this whole field now is to basically learn representations so that the vector directions of documents or words actually have a meaning that corresponds to something in the language. And so you can imagine, like on certain scales, certain concepts could be arranged kind of at least in an ordering, and they find they can do that. So it's actually very powerful. But like I said, once we explain how this method works, we'll talk about that tomorrow, and then we'll keep going from there. So Halim's got a question about frequency versus weight and significance. Yeah, it's not significance because we don't want to say this word's more important or what the probability of it is. So it's frequency isn't a simpler thing to count, right? It's like how often does it show up in how many documents, right? So that you're committing less. Significance is a loaded term, so you'd have to know more about it to say significance. But I think in more complex models, you could call these things significance. But at this point, it's just frequency. And Piyush asked about BERT, which is a kind of more recent common model. And yeah, after we're going to, so today and tomorrow, we're talking about the classic approaches. So we'll do Word2Vec and GloVe, which were kind of these things that came up with vectors and really used like very simple, essentially neural models to learn these encodings. But then we have to go and talk about, to understand BERT, we have to talk about deep learning more. So after we do deep learning, I will talk a little bit about BERT and transformers, but it'll be something more near the end of the course as an extra topic. And I don't know a huge amount about it, so I'll give you my understanding of it and point you guys to it. But yeah, if you're really interested in this area, BERT is a good thing to read about right now, B-E-R-T, as Piyush was saying. But it builds on some of these things, so it helps to learn these first. So after tomorrow, you can go read about that. We will talk about it later. Great. Okay, so I will talk to you guys tomorrow, and thanks for coming and your questions, and be well, be careful in the snow if you're here. If you're not here, enjoy the not snow. We're supposed to get like 10 centimeters today, so talk to you later.